Good evening, everyone. Hope I'm audible. Uh, just confirm this. Anyone can just confirm whether I'm audible or not in the chat box. Is my voice reaching you? Is there any technical issue or my voice is reaching you? Okay. So today we will discuss the descriptive questions, important questions for the descriptive exam. I mean, in our previous session, we discussed the objective bits, whatever important bits we have given. I have given the explanation because some of them were very unique for you, which we have not discussed in the class. But anyhow, I have given the clarity on what are those, I mean, how you can solve those bits in your exam. So today we'll do the same thing with the descriptive paper for mid one. So I'm recording this session also. I mean, if possible, I will share the recording with you. I mean, anywhere if you got any doubt, I mean, because some codes we will discuss in today's session. I mean, if you are unable to note those codes, later on you can play the video and you can watch the that program code. Okay, I recommend having a notebook with you, a pen with you while attending the class. So, anywhere, if any important point we are discussing or any important program which I am showing you, so that you can immediately note down and you can practice afterwards. So this is what we have. I mean, important questions for mid one. They have categorized the questions under four different categories. One is related to arrays. They asked few questions. Around 13 questions are there under these arrays. Then we have loops. Under loops, around eight questions we have, and these pattern programs, once again eight different patterns, and finally, yeah, this conditional statements. Under this conditional, around 10 different programs, and finally this basic programs. In that, around nine different questions, or we can say 11 questions we have under it. Two are theory based and remaining all are programs. So as it is a programming subject, PPS, it is a programming subject. In the name itself states programming for problem solving. So a majority of the questions, almost 90% of the questions, you can clearly see in the important questions document. 90% of the questions are related to programs only. They're asking you to write programs only. Very few, I guess, around here only one is a theory question in arrays. So that also they are simply asking the definition, what is an array, and explain different types of array. Okay, only one theory question is there in the arrays topic, and under yeah, this basic programming, here two more theory questions. All in all, we can say only uh, three theory based questions we are having, and remaining all are programs only. And here two more, you can see here we have two more: explain conditional statement and explain switch case statement with syntax. These two also theory based questions, and remaining all, if you see, remaining all, they are program questions only. Okay, they are programs only. So as I said, now if you practice well the programs, and if you write well the program in your descriptive paper, there is less scope of losing the marks. If it is a theory question, even if you attempt, even if you wrote the complete topic, but there is I mean, less possibility that you will get full marks for that question. But if it is a program, and if you are coding well, and if you are writing the output, because output it Output is mandatory, ma. In your descriptive paper, when you write the program, immediately write the output as well. Don't just for that 1 minute or 2 minute, don't leave the output, because output itself carries 1 mark. Okay, whatever marks allotted for your question, output itself carries 1 mark. So if you don't write the output, simply that 1 mark you will lose. Okay, along with the program code, don't forget to write the output. So here in the arrays topic, the first question, as you can see, you need to define the array. What is an array? So we all know that. I mean, in our Saturday's class, we discussed. I mean, yesterday's class we discussed arrays topic, and there I have defined arrays many times. Okay, we said array as a collection first, isn't it? Array as a collection. Memory for array will be allocated in contiguous manner, and all homogeneous data items will be present inside an array. All elements of same data type, homogeneous type. All these definitions you can write, ma. All these points you can write under this definition. And they're asking explain different types of arrays. So types means only two types. Actually, three types we said, but only two types we're going to discuss as part of your curriculum. That also I mentioned. So one-dimensional array, two-dimensional array, and there is another one, multi-dimensional array. But we will discuss only the first two, one-dimensional, two-dimensional. You need to write what is one-dimensional array. Okay, you need to define what is one-dimensional array, and all the things, the syntax, how you do the I mean, yesterday's class, complete class, whatever I have discussed, how you do the declaration, how you do the definition, how you do the initialization, all that you need to write if they ask you to write about this. And same thing for two-dimensional arrays also you need to do. About two-dimensional arrays, so far we have not discussed. That we will do tomorrow's class, Monday in the physical class only. I will explain all the topics related to two-dimensional array, like how we do declaration, how we do definition, how we do initialization for the two-dimensional array, what are our possibilities with example demonstrations. I will explain in tomorrow's class. Okay, hope you got the clarity how to answer this first question. You need to define the array, and you need to write about 1D array and as well as 2D array, two-dimensional array. Okay, don't write anything related to multi-dimensional arrays. Okay, so the next thing is program to find sum of all elements of an array. So in an array, whatever items we are keeping, simply we need to find the sum of all of them. So already we have done one such program, not with arrays, but in a regular fashion, in a regular way we have done. Simply we read some n numbers while explaining loops. We did that program. We read we read some numbers from the keyboard, and we calculated the sum of all those numbers. Okay, so um, uh, I will explain how we do that one. So suppose if you have an array, something like this, integer, I'm taking the type as integer only, integer a of 5. This is how we create the array. We all know that integer a of 5 equals to, I'm assigning some values, say 3, 4, 7, 1, 9. So how the memory allocation will be for this one, I have explained to you something like this. 5 items it will take. Okay, then 3 will come here, 4, 7, 1, 9. Okay, this is index 0, index 1, index 2, index 3, index 4. So now what we have to do, we need to add all these numbers. That is nothing but we need to perform a of 0 plus a of 1, okay, plus a of 2 plus a of 3 plus a of 4, because we know that array index will start from 0 and ends at maximum size minus 1. This is what we need to do. Okay, so this we need to store inside a variable sum, and this sum we need to print at the end of the program. Okay, so but generally we don't do in such a way. We don't access individual elements in such a way. Rather, as it is repetition, you can see index is repeating over here 0 1 2 3 4 in such a way it is going like a series. So what we do, we take a loop. Okay, basically for loop we will take and we'll put something like this. Okay, so for I equals to 0, I must be less than the size. Here the size is 5, so less than 5. Then I plus plus. Okay? Then how, what we do? We need to simply calculate the sum. So sum is equals to sum plus, because previous result also we need to consider. Okay, sum is equals to sum plus a of I. This will give you the sum. Sum is equals to sum of sum plus a of I. So here in the first iteration, a of 0 will be added. In the second iteration, a of 1, third iteration, a of 2, fourth iteration, a of 3, fifth iteration, a of 4. Likewise, it will add all the numbers into this sum variable. Okay, array items, all items will be added into this sum variable. Finally, after coming out of the loop, print the sum. How we print? Printf take percentile or result or sum, like that you can give some message, result colon percentile d comma sum. This is how you can print the sum. Anyhow, I will explain, I mean I will do this in the Dave CPP. You can see here I'm taking a new file. Okay, and I'm saving it with okay, let's just write some code. Hash include stdio dot h, then your main function int main of void. Okay, then here declare the array a of 5 equals to, make that 3 comma 4 comma 7 comma 1 comma 9, something like this, whatever random numbers. Then to run the loop we need I. Then for I equals to 0, I must be less than the array size, which is 5, I plus plus. Okay, then perform sum. Okay, we need to declare this sum also here. So sum, it should be initially 0. Okay, sum is equals to sum plus a of I. A of I. That's it. Come out of the loop. Printf. Okay, here you can write sum of array elements colon space percentile d comma sum. That's it. Okay, now what will be the sum here? 7 7 14 15 plus 9 24. Okay, 24 as result we need to get. Now save this code. Taking like test.c. Okay, program got saved. Now compile. Spelling here include. Okay, compile. It got compiled successfully. Then run. You can see here sum it is giving 24. Okay, so this is how you can calculate the sum of array elements. Whatever elements has been given, sum of array elements you can calculate. Hope you understood, because many programs we need to discuss. So I will simply minimize this one and I'll go to the next program. So what it is asking me, it is asking me to identify the even elements from the array elements. Whatever array elements we are having, from that we need to identify the even elements. Okay, we know the code. We know how to check whether the given number is even or odd. Same rule we apply here. How we check generally to check whether the given number is even or odd? What we do? Uh, so here I'll put that one. So to check whether the given number is even or not, that is even or odd, we divide the number, we modulo divide the number. Given number, let us assume num. We modulo divide the number with 2, and if the result is 0, okay, this is your conditional expression. If this is true, we are saying the number is even. Okay, if the remainder is 0, we are saying number is even. And if the remainder is not 0, if this condition is false, we say the number is odd. So same this particular thing we need to apply on each and every element of the array. Okay, so how we do that one, I will show you. See, just go to your code. So here we know that a of I we are reaching. Okay, a of I we are reaching in this loop. A of I we are reaching. So now what we have to, if okay, in this, if this particular thing, this is nothing but our number, if this particular thing modulo divide with 2 equals to 0, then only print the number, otherwise don't do anything. Printf, okay, uh, percentile d, give some space, comma, a of I, a of I. Now what will happen, I will tell you how it will be done. Printf, here you print one message ma, uh, even what they're asking in the question, they're asking in the question to display the even elements. So even elements in the array are, so we know how many even elements, only one even element we are having, that is 4. Okay, simply we will check the result first, then I will explain how it is happening. Okay, save it. Now compile it. Yeah, here we forgot the semicolon in the printf statement. I'm keeping that now. So sum not required here. Just remove the sum. Okay, remaining all as is. Compile. It got compiled successfully. Then run it. As you can see, it is showing me only 4 as even element. Even elements in the array are 4. Okay, likewise it is doing. How it is happening, ma? So first we know that to access the array elements one by one, we need a loop. Okay, that is what, for that reason only we are taking this loop. So this loop will iterate as many items we are having in the array, that many times this loop will iterate. As we know the array size, which is 5. So here I will start from 0 to access the array items. I will start from 0 because array index will start from 0 and index will end at maximum size minus 1, that is up to 4. That's the reason we are taking here less than 5. Okay, so when I value becomes 5, what will happen? The loop will simply break and the control will come out. So this loop will iterate for I value 0, I value 1, I value 2, I value 3, I value 4. When I value becomes 5, the loop will break. Okay, because the condition becomes false, so the loop will break. And whatever if statement we are keeping, it is as part of your for loop. It is the body of for loop. Okay, and this printf statement, what we are keeping, it is the body of if statement. Okay, so after entering, first what will happen when the I value is 0, this 3 will come over here. At a of I, this 3 will come. In the first iteration, I value will be 0, so 3 will come over here. 3 modulo division 2, it is 1, because reminder, it is 1. So 1 equals to 0 we are saying. So what is that? This particular condition is false. So the control will not go here and will not print that number. Okay, hopefully you understood. Then in the next iteration, what will happen? I value becomes incremented. I value gets incremented. I value will become 1 now. So when I value 1, this 4 will come. A of 1, because this is 0, this is 1. Okay, a of 1, which is 4, will come. 4 modulo division 2, it is 0, because remainder will come 0. So 0 equals to 0, condition is true. And if the condition is true, this statement will be evaluated. So you will see 4. After this element, even elements in the array are, you will see 4. Then in the next iteration, I value will become 2, 7 will come, which is odd number, 7 modulo division 2, remainder 1, not equals to 0, condition false, this statement will not be printed. Again, one more time, I value gets incremented, I value will become 3 now, a of 3, which is nothing but 1. 1 modulo division 2, it is 1 only, reminder 1 only. So it will not print 1 also. Then one more iteration, I value becomes 4. When the I value is 4, 9 gets over here, 9 comes over here. 9 modulo division 2. Again, reminder is 1 only. So 9 will also not be printed. Okay. So simply only 4 will be printed, and that we are seeing in the output screen. Once again, I'm compiling and executing. You can see that 4 over here. Okay, something like this you can print even elements in the array, something like this you can print. Now we print the odd elements. What we have to do, odd means same program, but here not equals to, we need to make not equals to 0. Whenever the reminder it is not equals to 0, that is 1, we will get the number as odd number. And here we need to make this, in place of even, we need to make this message as odd, otherwise it will print even only. Okay, so make this as odd. These two changes you do, and now it will print your odd numbers. Just see. So whatever odd numbers we are having in the array, all that it is printing 3, 7, 1, 9, like this it will print. Hope you are understanding. Previously we printed even numbers, so we got only 4, but now we are printing the odd numbers. Same program, just we need to make this condition in place of double equals to, which is equals to, comparison equals to. Now we are making not equals to. Okay, hope you understood this program. Very easy program. Don't get confused. Simply one dimensional array we have created of 5 elements, and one I we are declaring to run the counter controlled loop. Then we are printing this message. Okay, just to have the clarity, what is the output, just to have the clarity, to make the output readable, we are using this message. Okay, odd elements in the array, previously even elements in the array are, now as we are printing odd elements, so odd elements in the array are. Simply this code you write along with this output you write, you will get full marks. There is no scope of reducing even one single mark. If you write 100% correct, as is whatever we have here, if you write 100% correct this program, there is no scope of reducing marks. Okay, uh, 3 marks means 3 marks you will get, or 2 marks means 2 marks you will get, full marks you will get. Hope you understood this question. Hope you understood this program. Okay, if you have any doubts you can post I'm checking. Is my voice clear, am I audible? It is still not clear, huh? Somebody posted that voice is not clear. Okay, okay, thank you, So then we'll go with the next, this even, odd, both we have done. Okay, even as well as odd, both we have done. So next is to identify, to find the max element in the array. Whatever elements we are declaring, just we need to identify the max element from the array. Max means the biggest number in the array elements. So if you see this array, our array, where it went, let me just drag it. Okay, sorry. Okay, this is our array. We can clearly know that the 9 is the biggest number here. Okay, 9 is the biggest number. Now how we identify, what we have to do means we need to take one variable, we make it as max. Okay, we make it as max with name max. We are taking one variable and initially assign this max to the first element. I will let you know, once again I'll draw that array over here. Okay, this is how, sorry, this is how our array we are having with 1 2 3 4 5. So take same 3 4 1 3 4 7 1 9. First, initially what you have to do, make this max as the first element, that is nothing but equals to a of 0. First element is nothing but a of 0. So do like this, max equals to a of 0. Then we need to iterate through a loop wherein we'll access elements one by one. As first item we are already assigning to 0, we need to start our loop from 1 index 1. Okay, as first item already we took inside max, so no need to compare the same item with max. Okay, so what we do from this number till end, okay, from 1 till end we need to compare all the elements with this max. Wherever any number is greater than max, simply we need to put that number into max. I will tell you how to do. So what to do, first take a loop for I equals to 1, not 0 I equals to 1, I must be less than 5 because 5 elements only, then I plus plus, like this you take. Then write one condition, if at all any number, that is if at all any number, say that is any number, how we write a of I, any number is greater than max. If any number is greater than max, simply what we have to do, make that number as max. So max equals to a of I, make that number as max, otherwise don't make. So simply if what it will do, whenever this particular condition becomes true, okay, that number will be assigned to max. I will tell you how. Initially, see what we are doing, we are making max equals to 3 first number we are making a of 0, that is nothing but 3. So initially max will be 3. So in the first iteration of this loop, this for loop, what will happen, a of 1 will come because I value will be 1 in the first iteration, I value will be 1. So a of 1, which is nothing but what, which is 1, sorry, which is 4. So 4 we are comparing with max is 3. So ఇక్కడ ఏమవుతుంది, first iteration what will happen 4 greater than 3 because max is 3. So this condition becomes true. In the first iteration this condition becomes true. So what will happen, what we are doing, max is equals to a of I, we are doing a of I is nothing but a of 1, that is 4. So we are assigning 4 to max. So max will become 4 now. Okay, in the next iteration I value gets updated, I value become 2 now. When I value is 2, then what will happen, a of 2 we are comparing, a of 2 is what, 7, a of 2, 7 greater than max. What is max, 4. So 7 greater than 4, 7 greater than 4, once again the condition is true. So what will happen, once again max will be altered with a of 2, a of 2 is 7, so max equals to a of 2, max equals to 7. So now max will become 7. So one more iteration, I value gets updated, I value becomes 3 now. So third element, sorry, fourth element, my index 3, that is fourth element. We are comparing fourth element now. So which is what? Which is 1. So 1 greater than max. Max is what? 7. So 1 greater than 7. Condition this time it is false. So no change, nothing will happen. Your control will not come here. Okay, whenever it is true, only control will come here. If it is false, control will not come here. It will simply go to the I value gets updated, I value becomes 4 now. So when I value 4, once again condition tested, 4 less than 5, condition true. Then here a of 4, that is nothing but 9. 9 we are comparing with 7. Okay, 9 greater than 7, again condition true. So what will happen, max will become a of 4. Max will become a of 4. I value is 4 now. So max will become a of 4. A of 4 is what? 9. So max will become 9 now. Okay. So max will become 9 now. After that, what will happen? I value gets updated. I value becomes 5 now. So when I value 5, what will happen? 5 less than 5. This condition becomes false. So control simply exit. It will not go to if, neither it will go to this statement. It will simply exit. So this is how the maximum value in the array will be identified and kept inside max. So here we are taking only 5 whatever size array you take. This is same logic. The same logic will be applied, will work with any size of array. Okay, hope you understood this program. So simply I will code and I will explain the complete thing over here. Okay, to run the loop, this particular thing we will take, and here we need to take max as well. Okay, max as well. So here you print one statement, what max element in the array is, max element in the array is. Likewise, or else you can print even after the loop also. Here you can print. Only for this program after the loop will work. Okay, because from the loop we will not print anything. So here what we have to, this whole thing you simply remove. Okay, so before coming to the loop, make max as a of 0. Okay, a of 0. Now I equals to 0. I no, we need to start from 1 because a of 0 already we assigned to max. I equals to 1. I must be less than 5. I plus plus. Then a of I is greater than max. If this is true, make max as a of I. A of I. That's it. Okay, now come out of the loop. After coming out of the loop, max element in the array is percentile D, and that element will be available inside max only. Like this you can print. Okay, this simple program will give you the maximum element, the biggest element in the array. So you can clearly see that one. Yeah, we are getting 9. So max element in the array is 9. So like this you can print. Hope you understood this one. Simple logic, ma, no confusion, simple logic. So how you identify the minimum element now? That is what our first next question, I guess. So identifying the minimum, minimum element of the array. Program to find min element of the array. Okay. So how you do it? Simply in place of greater than, you make it as, first you need to change this variable name. Make it as min. Okay, min. Here also same min. You need to assign the min to the first element only. From the first element only you need to start, and you need to compare all the elements. Wherever you find the minimum element, your min will become that element. So here you need to make it as less than. Okay, if the given a of I is minimum than minim, okay, minimum variable, then make min as a of I. That's it. Here min element, minimum element in the array is percentile D, and print min only, minimum. Okay, accordingly we have done the changes, changed the variable name min we made, and we are comparing the array element with min. Okay, and if it is true, then we are making that immediate element as the min, and we are printing. Finally, when you are coming out of the array, the minimum will be available inside this min variable. The same thing we are printing over here inside min. Save it, compile it, run it. You can see minimum is 1 now, so it is printing 1. Hope it is clear. Minimum element in the array is 1. Hope it is clear. Okay, so not to worry, this whole video, it is getting recorded. I will share with you later on. You can watch the video, and wherever you want to pass, you can pass. And if at all you got any doubt tomorrow in the class, you can ask, or anytime on the WhatsApp you can post. Or every day we are conducting evening classes as well, doubt clarification classes. So in the doubt clarification class also you can ask. Not to worry. Okay, so next is printing program to display array elements in the reverse order. Very simple program. Just you need to take the array loop. Okay, whatever loop we are taking, not in the forward direction, rather in the reverse direction, you need to take that loop. Okay, and that loop will print all the items. So here I will explain that thing. So simply see. So here when you are having array elements, something like this, same I will take integer a of 5 equals to 3, 4, 1, 7, 9, something like this, 5 elements when you are taking. So we know that memory allocation for this one, once again I'm explaining, like this it will be 5 elements. So 3, 4, 1, 7, 9, 1, 7, 9. This will be your 0, 1, 2, 3, 4 index. Okay. Now, what we are doing generally to print the array items in the forward direction, in the actual direction, what we do, for we'll take one variable I equals to 0. We are saying I less than the max size. Okay, here it is 5, so 5 I plus plus, like this we are running a loop, and then we are printing the inside element, printf percentile d comma a of I. This will print all the array items in the forward direction. So now what we have to, we need to print the array items in reverse direction. Reverse direction means the, from here we need to start. From max minus 1 we need to start, and we need to decrement the counter, and we need to reach 0, and we need to stop. That is how it will be. For max minus 1, array equals to max size minus 1. That is nothing but 4 in this case, because max size is 5 minus 1, that is 4. Then condition I must be greater than or equals to 0. Okay, greater than or equals to 0. So when I value reaches 0, uh, it will print the last item from the array, that is 3. And because we are moving in the reverse order, from here we are moving in this direction. Initially I value will be 4, then we need to decrement the I value. So I minus minus you can take. Okay, now first I value becomes 4. uh, Here you can write one statement. Let me just take it down. Okay, here you can write printf array elements are, array elements are colon, close it, semicolon. Okay, now this statement will come. After that, inside it print all the items, printf space percentile d comma a of I. That's it. All items it will print in the reverse order. Okay, here you can mention array items in reverse order, in reverse, or like that you can print. Okay, I will give you the full clarity on this thing by executing the program. So simple easy peasy program, not to worry about it. So what we do, we'll go to here. So simply we need only the counter, we don't need this also. Okay, so this will, what it will do, if you take the loop like this, but you need to start from 0 here. Okay, here you print one message, printf array elements are, like this you can print. Keep one semicolon at the end. This loop you take, then print the items, printf percentile d, here you can give space, then dot a of I, like this, comma a of I. Here you can keep backslash n just to have the numbers in next line. Okay, now what you will get, just save it, see compilation, then execution. We are getting like this 3 4 7 1 9, whatever elements we have initialized, that same elements in the forward direction it is printing, in the actual direction it is printing 3 first, then 4, then 7, then 1, then 9. Now what they are asking, they are asking us to print in reverse order. So how we do that one in the reverse order? Here I'll make that note, reverse order, reverse order R. What I said, I value initially make it max minus 1, that is 4. Okay, then I should run, it should be greater than or equals to 0, and I should be minus minus. That's it. Save it. Now you can see it will print the elements in reverse order. You can see 9 1 7 4 3. That is what they are asking us to do. Okay, array elements in reverse order. Array elements reverse order are, down we got all the numbers in reverse order, 9 1 7 4 3. Hope you understood. So coding in this way only you need to learn continuously, you need to practice the code, then only you will come to know how to write the code. Okay, so here you take one in reverse order R, that is what they are asking, I guess. Yeah, in reverse order. So simply array elements in reverse order R, then print like this. So hope it is clear for you. So like this we will get the output. Okay. So from now on, whatever we have now, this whole things from program 8 till program 13, sum of two matrices, product of two matrices, printing the diagonal of a given matrix, printing the transpose of a given matrix, finding the sum of all elements of a matrix. Okay. Program to find max element in the matrix. So all these will do tomorrow. Tomorrow in the class we will discuss the theory related to two-dimensional arrays. I'll make you aware how to declare, define, initialize a two-dimensional array and how to process all the elements in the two-dimensional array. Then maybe in tomorrow's evening class we will discuss this thing. These programs we will discuss. Okay. Then the second category, loops we have. So program to display multiplication table. This already we have done in the lab. We have done this thing. Okay, multiplication table. Okay, finding factorial of a given number. So factorial means it's very simple. Factorial means what we do. I will write here the logic for factorial. What we do, factorial. Suppose if our number is 6. Okay, we need to identify the factorial of 6. Then what we do, we start from 1 and we multiply all the numbers from 1 to 6. This is how 3 multiplied with 4 multiplied with 5 and finally multiplied with 6. Like this we need to do. So how we can achieve this one? As you can see here, the numbers are incrementing in series, isn't it? One by one, like that it is incrementing. So we will take one variable known as fact, where we store the factorial. Okay. So what we have to, this number initially it should be 1. Then we need to multiply this with first number, second number, third number, fourth number, fifth number, likewise up to that number, up to n. All numbers we need to multiply and finally we need to store the result in this one. So logic is very simple. I will write here, you can see, for I equals to, we need to start from 1. Don't start from 0, because if you start from 0, the complete factorial will become 0. Okay, so start from 1. Okay, then I must be less than or equals to given number. Here it is 6, so 6, or else we'll read the number, okay, from the keyboard, so make it as num. Then I plus plus, we need to move in the forward direction. Here what you do, fact equals to, because previous result with previous, here when we are multiplying 2 with 3, previous result also we are considering. 3 with 4 means here previous result. How we do? 1 multiplied with 2, 2, 2 multiplied with 3, 6, 6 multiplied with 4, 24. Likewise, previous result, with previous result we are multiplying every number. So here also we need to do that one. Previous result will be available inside fact. So make it fact multiplied with I, like this. So come out of the loop and print the factorial. That's it. Simple logic now. So here in every iteration, first iteration 1 will come, second iteration 2, 3, 4, 5, 6, like that all numbers up to the given number it will read. Inside the loop it will take, and all those numbers we are simply multiplying with fact and storing into fact. So when you come out of the loop, the factorial will be available. Factorial of the given number will be available inside this fact variable. Okay, I will simply show you here. Delete this whole thing. Here you make it n comma I, and initially, as I said, now make it num and I, something like this. Then printf, enter any number. Okay, here for the understanding you can write factorial like this. Okay, then go to the end and put semicolon, then read that number, scanf percentile d, read that number into num variable. Okay, now run the loop. For I equals to 1, start with 1. Factorial we are calculating, multiplication we are doing, so compulsory I value should start from 1. If you make the I value as 0, the whole factorial will become 0. So be careful about it. So we need to run up to the number equals to number and I plus plus. It is not something array index. So we need to run the loop up to the number, because when you are calculating the 6 factorial, you are including 6 also in that multiplication. So now find the fact also we need to declare here. So make fact, initially make it as 1. Okay, then come here, fact equals to fact multiplied with I. Okay, then come out of the loop. After coming out of the loop, print, uh, here you can put something like this, factorial of percentile d is percentile d. Percentile d. Two times I'm using my percentile d. First, what I want, suppose if you are calculating the factorial of 5, so that 5 will be available inside this number, because we are reading that 5 from the keyboard, and that 5 will be available inside this num. So now how we do factorial of percentile d. So first percentile d I'll make num, and the second percentile d I'll make the result, which is fact. So now how it will be? So factorial of the red number, factorial of red number, in place of percentile d, that number will be printed, is the result we have calculated, that will come over here. So suppose if you are calculating the factorial of 5 factorial, how much it is? Okay, 1 multiplied with 2 multiplied with 3, 3 to 6, 6 fours 24, 5s, around how much it is? 120. Okay, we will see. Okay, then save it, run it. So it is asking you to input any number. So if I am inputting 5, something odd happened. Here you can see, while reading the number, I forgot to put the and percent. Save it, compile it, run it, then you put 5. So it is giving us the 120 result. Okay, factorial of 5 is 120. So as you can see, first percentile d got replaced with the number which we read. Okay, and second percentile d got replaced with the result which we have calculated. So like this you will get factorial of 5 is 120. Hope you understood. Very simple program, factorial, finding factorial. This we call iterative approach. There is one more approach, recursive approach, that we will see after functions. So for now you go with this program only. Hope it is clear, ma. So next thing, factorial we have done. So checking prime or not. Okay, this we will discuss afterwards. There are some easy programs down that we will discuss first. So prime number program, afterwards we will see, ma. Prime number. Then they are asking program to count number of digits in a given number. Okay, sum of digits, counting the digits, and palindrome. These three, they are reverse of digits and palindrome. These three are equal, same category of programs. Even Armstrong also same category of programs. So we leave this prime number. We'll do afterwards. I will explain these. Counting the number of digits, sum of digits, checking whether the given number is Armstrong number or not, reverse of a digit, and checking whether the given number is palindrome or not. All this will do, and will conclude today's session. Hopefully in 10 minutes, hardly in 10 minutes, I will complete all these four or five programs. Okay, then we have patterns. See, few patterns I have explained to both the sections, like printing this pyramid kind of patterns, this triangle kind of patterns. This is not pyramid, triangle kind of patterns. I have explained in all the sections. I mean, omega section as well as beta section I have explained. Printing in reverse, I think I have explained only in beta section, not in, sorry, in omega section, not in beta section. So beta section, I request you can take the code from omega section people. Okay, I have explained there. The programs are very easy, just two for loops only, nested for loops only. All these programs we can do with just two nested for loops. Okay, nesting of for loops. If time permits, I will explain in tomorrow's class to you. Otherwise, you can take the code from omega section people. Okay. Then these conditional statements and basic programs in tomorrow's session. After explaining the second part of this matrices, all this, I will explain these. Okay. Uh, so let me just go with these ones. Sum of digits, Armstrong number. First, I will explain the logic behind all these. What exactly we have to do when we are saying sum of digits of a given number, reverse of digits of a given number, palindrome of a given number, counting the digits in a given number, Armstrong number. All these I will explain. Let's just see here. First, let us assume our number, because sum of digits of a number we said now. So let us assume our given number is uh, this one. Number means more than one digit. Obviously, single digit also we can call it as number only. But here when we apply the logic now, we'll consider more than one uh, digits. So 1, 3, 7. Let us assume this is our number, given number. So now what do you mean by sum of digits? Sum of digits. Many times this program they will ask in the exams, very important program, sum of digits of a given number. So this is our given number. So now we need to identify sum of digits. Sum of digits means, as we have three digits over here, 1, 3, 7. So simply what we need to, 1 plus 3 plus 7. How much it is? 11. This is what we need to identify. Whatever number they will give, simply we need to sum the digits and we need to print the sum. This is what sum of digits. Then another one is counting the digits in a given number. Same thing. Count of digits. How many numbers we have? How many digits we have in that number? Count of digits. Count of digits program also they will ask many times. Count of digits, as we know, 1, 2, 3. 3 we have. 3 digits we have in that one. So count of digits we need to print as 3. Reverse of number. Reversing. Reverse of given number. Given number. Reverse of given number. What we have to do here, as we have 137, simply we need to print 731, reverse of the number. Okay, then we have one more. What is that? I forgot. So count of digits we did, sum of digits we did, Armstrong number. Armstrong or not. Armstrong number or not. So Armstrong means, suppose if you have n number of digits in your number, n number of digits. So here A, B, uh, sorry, our number we said now 137. So first I will explain the logic. Suppose if you have A, B, C, to check whether this number is Armstrong or not, what we have to do means, uh, first we need to identify how many digits we have. Here how many digits we have? 3 digits we have. So make n, let us say make n as that number. So here 3. So now what we have to do, a power n plus b power n plus c power n. So this should be equals to ABC again. This should be equals to ABC. If this is true, sorry, if this is true, then the number is Armstrong number. If this is true, then the number is Armstrong number. Otherwise, it is not Armstrong number. Failing this, it is not an Armstrong number. Okay, not an Armstrong number. Hope you are understanding. I will give some example. Take our example only. If your number is 137, then this is your ABC. A will become 1, B will become 3, C will become 7. Then what is N? How many digits we have? N is nothing but, here I will write number of digits. Number of digits. Take down this in your notebook. If you are noting, take down this. Okay, N means number of digits. So ABC, n value 3. Then what we have to, we need to do this one, a power n plus b power n plus c power n. So how much it is? A power n means 1 power 3 plus 3 power 3 plus 7 power 3. We need to identify this, and whatever we get now, that should be equals to 137 only. So this is how much it is, ma. Let's just calculate here. 1 power 3, it is 1 only, plus 3 power 3, it is how much? 27. Okay, plus 3 multiplied with 3, 9 multiplied with 3, 27. So now 7 multiplied with 7, it is 49. Let me just open the calc here. Okay, so 7 multiplied with 7, it is 49. Multiplied with 7, it is 343. Here it will come 343. Obviously, it is not a Armstrong number. Okay, it is not an Armstrong number. So how much it is total? Here this side it is 137, and this side how much it is? 27 plus 1 plus 343. 343. It is 371 somewhere. 371 equals to 137. Okay, 137. Obviously, clear that it is not an Armstrong number, because this condition it is failing, so it is not an Armstrong number. So I will give an example for Armstrong number. Ma. Take 153. 153. Okay, now you try to calculate whether it is Armstrong number or not. So how much it is? Again, this is A, B, C. So A value is 1, B value is 5, C value is 3, and N is equals to 3 digits we have. So what we need to calculate? 1 power 3 plus 5 power 3 plus 3 power 3. It should be same as equals to 153. Then we call this number as Armstrong number. So now this is 1 plus 5 power 3, how much it is? 125. And 3 power 3, how much it is? 27. So if you calculate this, it is equals to 153 only. Ma. See, 126 plus 27. So 126 plus 27, it is equals to 153. So 153 equals to 153. So it is an Armstrong number. This statement, it is true. So it is an Armstrong number. Armstrong number. So hope you understood Armstrong number, concept of Armstrong number. So then we have the last thing, one more thing we have, that is checking whether the given number is palindrome or not. So palindrome means when you reverse the number, you should get the same number. Here I will write that logic. Palindrome number. So suppose if we are having 1, 2, 2, 1, or 1 to 1, take only 3 digits, 1 to 1. So what happens if you reverse this number? Same. After reverse, actual number is 1 to 1. If you reverse the number, reverse also, it will become 1 to 1 only. So if this is true, if the number and the reverse of the number, if both are same, we call that number as a palindrome number. If it is not, we don't call it as a palindrome number. Suppose if you have 137, this only, our regular number, then what will happen, ma? The reverse of this number, when you reverse, you will get 731. As you can see, these both are not equal. So it is not, 137 is not a palindrome number. But 121, even when you reverse, you are getting same number, 121 only you will get. So 121 is a palindrome and 137 is not a palindrome. So all these we need to do. So step by step we will go. I will not take much of your time. So here sum of digits we'll do first, then count of digits we'll do next, reverse of a given number we will do, then Armstrong we will do, and finally the palindrome number we will do. With that, I will conclude today's session. So first, sum of digits. So how to do that sum of digits? Sum of digits concept we understood, but how to do that? So here I will explain sum of digits. Sum of digit. So somehow what we need to when you are having that number 137, somehow we need to separate these digits one by one. We need to separate the digits, and then we need to add those separated digits into another variable, and so that we will get the final results. I will tell you how to. So see, 137 we are having, right? So if you say 137 mod 10, because we need to perform modulus operation with 10, what you will get, Reminder you will get. So 137 modulo division 10. What is the reminder? 7 you will get. See, 7 we have separated. 7 we have separated. So now what you do after modulo dividing with 10, now you divide this number with 137, divide with 10. Then what you will get? 13 you will get, because 13.7 actually you will get, but if you store that 13.7 into a integer, what you will get? 0.7 will be truncated and you will get only 13. See, last digit we got, store this digit into sum. Okay, add this digit into sum. So sum will become 7 here. Initially sum will be 0, now sum will become 7. Okay, after separating, once again what you do? 13 modulo division 10. So this time what we are separating? This time we are separating 3, because 13 modulo division 10, you will get 3. See, 1 we have separated, 7 we have separated, 3 we have separated now. So after this, once again 13 divide with 10 you do. 13 divide with 10 you do. Now what you will get? Only 1 you will get. Okay, 1 you will get. So here this 3 you have separated, that 3 you add to sum. Previously sum was 7, now you make sum is equals to sum plus 7. Sum plus num, like this. Okay, sum plus a reminder. Actually we call it as reminders. Every time we are getting reminders. So reminder. So sum plus reminder. So now what will happen? Previously sum was 7, now we got reminder as 3. So 7 plus 3, sum will become 10 now. Sum is equals to 10. Next one we have, one more time, 1, this is not modulo division, this is division we are performing here. Now 1 modulo division 10, we will get what? 1 only we will get. 1 only we will get. So again 1 you add to sum. So sum is equals to 10 plus reminder. That will be 11. Okay, we got sum as 11. And one more time, 1 divided with 10. This, wherever you are performing this operation, the final result will become 0 here. Okay, final result will become 0. So our loop, whatever loop we take, here we take while loop generally, and we'll make whatever value we are calculating, that num, it must be greater than 0 always. When this num goes to 0, we terminate the loop, we come out of the loop and we print the sum. Okay, I will write the program so that you will understand. So here you can see that, declare one variable, say num. Okay, then reminder also we need to store, and then sum, it should be equals to 0 initially. Okay, then printf, read that number. Okay, so enter any number, in bracket you can write sum of digits, because you are performing sum of digits. Okay, then read into num, scanf percentile d comma ampersand num, we got the number. Then take while, and this num should be greater than 0 always. Okay, So now what we do in a loop, calculate remainder. Remainder is equals to num modulo division 10. It will separate digit by digit. Whatever digits you will, whatever numbers you will take, it will separate digit by digit. Then sum is equals to uh, sum plus remainder. Sum plus reminder. Sum is equals to sum plus remainder. Then lastly, remainder is equals to remainder. Num is equals to num divided with 10. Like this, you can simply run a loop, and after coming out, you can printf sum of digits percentile d, where it will be available inside sum only it will be available. That's it, simple program. Okay, this will give you the sum of digits. Run it. You can see it is asking me to input the number. So suppose if I input 137, we are getting 11. 3 plus 7 plus 1, 11. Okay, take another just for our curiosity. Okay, I'm taking 1427, something like this I got. So 7 plus 2, 9, plus 1, 10, 4, 14 we need to get. 14 we got. Okay, this is how you can calculate sum of digits. Sum of digits. Now counting the digits, it is dead easy. Counting the digits, we no need to calculate sum. Okay, so just remove the sum. Okay, read the number. We no need to calculate the sum. So here what you do, simply take one variable, count variable. Initially make it 0. Okay, so here you make it as count plus plus. That's it, count plus plus. So when you come out, count of digits, here also instead of sum, make it as count of digits. Count of digits, where it will be available inside count it will be available. That's it, because in every iteration we are separating a digit, and when we are separating we are counting it. We are counting it, and then when the num value goes to 0, that final count will be available inside this count variable. Okay, so run it. See, if I input 1427, four digits we are having in that number, count of digits, it is printing 4. This is how you can simple corrections, same program, simple corrections. Okay, hope you are understanding. So sum of digits we have done, count of digits also we have done. Okay, then what else we have in our list? Sum of digits, count of digits, these two we have done. Armstrong will do our last, we do Armstrong. Reverse of a digit. Okay, reverse of a digit and palindrome, these two we do. Reverse of a digit, it is also pretty simple, so this same logic we follow. Same logic. Here you simply remove this one, but now count, no, instead of count here you make reverse of digits. Okay, reverse of digits. Here instead of count, because we don't need count now, take reverse. Okay, take reverse, and initially make it 0. Okay, okay, the number we are reading, and the logic here is simply reverse equals to reverse multiplied with 10 plus reminder, whatever reminder we are calculating. Same logic, only the center line will change. For 3 programs, only center line will change. Here count in place of count, reverse of digits. And here where the reverse will be available, inside REV variable it will be available. Okay, that's it. Reverse of variables. Now just save it, compile it, run it. Here you input same thing, 1427. See, 7241. Reverse, exactly reverse we got. Okay, exactly reverse we got. So this is how we can print the reverse of a digit. reverse of a number. Okay. Then the last one, palindrome. Palindrome means both reverse and actual number should be same. So what you do, take another number here, old num. We are taking two number variables because here whatever we are doing now, actual number will get affected. So before affecting the actual number, we need to store it into old number, because after reversing, we need to compare the reversed number with actual number, isn't it? Compare the reversed number with actual number. So that actual number we are storing into old number. So after reading it, just copy it. How we can copy ma? Old num equals to num. Now the actual number will be available after this loop also. Actual number will be available inside this old number. So now to print the palindrome thing, okay, palindrome thing, we need to take one if loop. If condition we need to take, if old num equals to num. Okay, if this is true, okay, print the number as palindrome. Percentile D is a palindrome because the number which we are reversing will be available inside reverse. Okay, will be available inside reverse. So the number which we are reversing and the actual number both are same. Here both are same. So we are printing it as, if this is true, that means both are same. So print the number as palindrome. How come? Percentile D is a palindrome. Palindrome. Here you make that one. Instead of reverse of digits, palindrome. Like this you can make. Okay. So simply we are checking whether the given number is a palindrome or not. Okay. Palindrome. Otherwise, else you go and print. Printf percentile D is not a palindrome. And what is that percentile D? Your old number. Okay. Before the loop, whatever number you had now, that old number you need to print here. Okay. Save it. Now just compile it, run it. Okay. It is asking you to input any number. Suppose 1427. It is not a palindrome. 1427 is not a palindrome. So suppose if I put 1221. Okay. If I put 1221. 1221 is a palindrome, because even if you reverse, you will get the same number. Hope you understood this one. 1224, 1221 is a palindrome, but 1427, it is not a palindrome. Okay, hope you understood. Same thing. Hope you understood. Then reverse of a given number, palindrome we did. Armstrong number we do ma. Armstrong number, and with that only we will stop. Okay. Same logic. Armstrong number also, the same logic we apply here. So here what we do, we'll take same old number we need to read. Here only the concept will change when you are calculating the Armstrong formula. So we call it as ARM. Okay, ARM. Instead of reverse, make it as ARM. ARM. Armstrong number. Here you make that one Armstrong number. Armstrong number. Okay, inside number we are reading the number and make old number as num, because here we need to compare old number with Armstrong. Okay, both are equal. Percentile D is an Armstrong number. Percentile D is an Armstrong number. Otherwise, percentile D is not an Armstrong number. Like this we need to print. Okay, this only this logic, and in this also this first statement is same, last statement is also same. Only this particular thing will change, because every time arm equals to arm plus of, reminder, power 3 we need to do. So how come? Reminder multiplied with reminder multiplied with reminder. That's it. Okay. So this is how arm initially it will be 0, and then this is how. So I told you now, I have given the example for Armstrong number we exercised here. Let me just go to that thing. Yeah, here. See, 137, we said it is not an Armstrong number, but 153, it is an Armstrong number. So I will give you both for you. So just save it, compile it, run it. First, I will make what is that? What's the number which we practiced? Here we practiced 137. So let me just give that 137. It is not an Armstrong number. But when you do with 153, just do with 153. Okay, here, let me just compile it, execute it, and make it 153. You can see 153 is an Armstrong number. It is printing. Hope it is clear for you, ma. If you got any doubts, you can post me on WhatsApp, or you can discuss in the classroom. You can ask me in tomorrow's online class as well. Okay. Hope everything, whatever we discussed in today's class, it is crystal clear to you. I'll post the recording also, ma, in your WhatsApp group. Maybe it will take some time because I need to upload it on YouTube. Then I need to share the link in your WhatsApp group. So it may take like 1 hour, 2 hours. So just be patient. After that, you can exercise. I mean, you can watch the video, and wherever you want, you can pause and you can check the uh, things. Okay, copy the code and other things. Okay, thank you very much, ma, for joining today. Tomorrow also there will be a session on same question paper discussion only. I mean, objective type questions. Sorry, not objective type. Important questions discussion only. So this is what we have today. Same thing we will discuss tomorrow also. Thank you. Thank you very much.